Okay, geometry, today we are starting a brand new unit. We're going to be looking at unit 6 here, and that's all about similarity. So when we're talking similarity, we are going to be talking about the same shapes but different sizes. And we're going to need some tools to compare those sizes, and our best way to do that, at least for right now, is by using ratios and setting those ratios up into proportional equations. So first section here, we're going to kind of leave the geometry for next time, and we're going to be doing some algebra here. Okay, so what is a ratio? A ratio is a comparison of two or more quantities. So two or more, but we do need at least two. So we have a few different ways that we can compare a ratio, that we can write our ratio. And the first one is a fraction. So that would be something like A over B. Our second one is that we can use a colon. So A to B right there. And then our third one is we can actually just use the word to. So A to B. And these all read the same way, A to B, but we just write them different ways, and they simplify a lot like fractions. In fact, they simplify exactly like fractions. So ratios can be simplified. Okay, let's look at a couple examples of these in action. We'll get some ratios from our music store example here, and then we'll simplify them down into simplest form. Okay, so first off, a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 bones in stock. And we want to write each ratio in simplest form. So the first thing we need is trumpets to violins. So let's see, there are 40 trumpets, and there are 24 violins. So we've got our ratio, but it's not in simplest form because there is a greatest common factor other than 1 that can be taken out of both of these numbers. So if you look carefully here, we see that 40 can be divided by 8, and 24 can also be divided by 8. So once we divide both of those numbers by 8, we get a new ratio of 5 to 3. And that is our answer there, 5 to 3. Those are both prime numbers, and they cannot be simplified any farther. Okay, let's look at number 2. Number 2, we are looking at flutes to clarinets. So in the box there, go ahead and write down this ratio of flutes to clarinets in simplest form. Okay, let's take a look here. We've got 51 flutes, and we've got 39 clarinets. So if we want to simplify that, we need to look for a greatest common factor. And something, a nice little number trick is if two numbers, or if the digits of a number add up to something that's divisible by 3, then that entire number is divisible by 3. Well, 5 plus 1 is equal to 6, so I know that 51 is divisible by 3. And 3 plus 9 is divisible by, or 3 plus 9 is 12, and that's also divisible by 3. So both of these numbers can be divided by 3. And when we do that, we end up with 17 to 13. And once again, we've gotten down to prime numbers, so that means that this will not simplify any further, and our ratio of flutes to clarinets is 17 to 13. All right, let's look at another one here, trombones to trumpets. So order does matter here. Last time we had trumpets, we put it first. This time we need to put it second. So go ahead and in the box, put in the ratio of trombones to trumpets. Okay, we've got 16 trombones, we've got 40 trumpets, and just like in number 1, it looks like our greatest common factor is going to be 8. So once we divide both of these numbers by 8, we end up with 2 to 5. All right, and then lastly, we need to compare violins to total instruments. So violins, that's easy. It's given to us right here, 24. But how many total instruments do we have? Write that in the box there. Okay, hopefully you counted it up correctly, and you got 170. Now in the box, go ahead and write down the ratio, simplified ratio, of violins to total instruments. Okay, so the greatest common factor between these two numbers is actually just 2. They're both even, so we can definitely take out a 2. But when we do that, we end up with 12 to 85. And 85 is 5 times 17, and 12 is 2 times 2 times 3. So there are no common prime factors between them anymore. These two numbers are what's known as coprime, which means that their greatest common factor is 1, and that means that we're done with the ratio. The final ratio here is 12 to 85. Okay, let's move along and look at extended ratios. So an extended ratio works the exact same way, only now we're looking at a comparison of 3 or more quantities. And extended ratios are always written with the colon. So we would look at something like A to B to C. Okay, so let's use these extended ratios for solving some equations, or solving some problems using equations, I guess I should say. So let's see. Number 5, the ratio of two complementary angles is 3 to 7. Find the measures of both angles. So first off, we need to go back and we need to remember complementary angles add up to what? Okay, complementary angles add up to 90 degrees. Supplementary add up to 180 degrees. They're in alphabetical order. So I know that these two angles are going to add up to 90 degrees. So something is going to equal 90. Now, if you think about what we did above here, when we were reducing our ratio, we were dividing out the same number. So let's call that number x. So we know that 3 times x plus 7 times x is equal to 90. Because when we divided out that x, which is just going to be some real number, then we ended up with 3 to 7. Not just some real number, some integer. We ended up with 3 to 7. So we can say that 3x plus 7x, that equals our original 90 degrees. And from here, we've got something that's just pretty easy to solve. So 10x is equal to 90, which means that x is equal to 9. And then always be careful and ask yourself, what is the question actually asking? And it's asking us to find the measures of both angles, so we need to multiply into here. So we've got 3 times 9 and 7 times 9. So our two angles are 3 times 9, 27 degrees, and 9 times 7, 63 degrees. And you can go ahead and check that in your calculator, but those two do add up to 90 degrees. Okay, number 6 I will leave for you. And number 7, let's look at a triangle. So the ratio of the measures of the angles in a triangle is 4 to 7 to 9. Find the measures of the angles. So go ahead and see what you can do here. In the box, just go ahead and see if you can solve this before I go through it. Okay, just like above, we know that to get to that 4 to 7 to 9, we had to take out some kind of common factor. And we'll just call that x again. So we ended up with our three angles being 4x, 7x, and 9x. And then because this is a triangle, we know that those three angles have to add up to 180 degrees. So now we've got an equation in one variable that we can solve. So that gives us 20x, when we add up that left side, is equal to 180. And if we divide both sides by 20, we get x is equal to 9. Okay, and then it's asking us to find the measures of the angles. So I'm just going to go ahead and substitute a 9 in for x in all three of these. So our three angles are going to be equal to 36 degrees. Let's see, 63 degrees, and 81 degrees. And if you go ahead and you add those up in your calculator, you'll see that those do add up to 180. Okay, I will leave number 8 for you. I will look at number 9 though. So number 9 says the ratio of the measures of the sides of a triangle is 2 to 8 to 9. The perimeter of the triangle is 76 inches. Find the length of each side. So we only set things equal to 180 if we're talking about angles. This is a very, very common mistake. If we're talking about sides, we need to know the perimeter, which in this case they gave us was 76 inches. But other than that, I'm going to set it up exactly the same way. I'm going to say 2x plus 8x plus 9x is equal to 76 because we had our 3 original sides and we divided out some greatest common factor of x that got us the ratio of 2 to 8 to 9. So from here, let's go ahead and solve this. 19x is equal to 76, which means that x is equal to 4. And now we can find the lengths of all of these sides. They are 8 inches. And let's see, the next one, 4 times 8 would be 32 inches. And then the final one would be 36 inches. And there is our solution. So I'm going to leave number 10 to you. And we are going to move along to looking at proportions. So what is a proportion? It's an equation. So a proportion is an equation that states that 2 ratios are equal. And in this case, we're going to want to write these ratios as fractions. So our proportion is usually written as something like A over B is equal to C over D. And then we have something called the cross product property that says that for any proportion here, we've got A times D is equal to B times C. And let's go ahead and just see why that works. So AD equals BC. And then maybe over here in this blank space, let's do a little bit of algebra and let's actually prove this. It's a very short proof. So we know that B and D cannot be 0 because they're on the denominator. They are the denominators of fractions. So what we're going to do is we're going to multiply both sides of this equation by BD, and we know that that's just some real number that's not 0. So let's go ahead and do that. Let's see, let's change this to red. So we're going to multiply the left side of this equation times BD, and we are going to multiply the right side of this equation also times BD. And let's see what happens when we do that. Let's get out a blue pen here. When we multiply B times D times A and then divide it by B, what's going to happen is that these two B's are going to go ahead and cancel each other out. So down here on the left side of the equation, we end up with AD. And then something similar is going to happen on the right side of the equation. We've got C times B times D, and that's all over D. So these two D's are going to cancel out. And that leaves us with the equation of AD is equal to BC. So we're just cross-multiplying, I guess, is what it's called a lot. Okay, let's just solve like 1 or 2 of these, and then we'll be done, and you'll finish the rest. So if we look here, we want to solve each proportion using the cross product property. So that means we're looking at 4 times 7 being equal to 2x. Well, 4 times 7 is 28. And then we can divide both sides of this equation by 2 and get that x is equal to 14. And there's our answer. Okay, I'm going to have you do number 12. So what does x equal in number 12? Okay, we're going to look at 12 times 19, and that's going to be equal to 10x. Let's see here. 12 times 19, 12 times 20 would be 240. And I know that I need to subtract a 12 from that. So that gives me 228 is equal to 10x. And then if I divide both sides by 10, that's the same thing as just moving the decimal one place to the left. So we end up with an x that's equal to 22.8. And there is our solution for that one. Okay, we're going to do one more because I do want to mention before we move along that you have to be careful with your distribution. When you're cross-multiplying all of the terms together. So in number 13 here, we're going to have 19 times the quantity, x minus 1, is equal to 13 times 6. So we need to distribute this 19. So that gives us 19x minus 19 is equal to 13 times 6, which is 78. And then from here, let's see, if we add 19 to both sides, that gets us 19x is equal to 97. And if we just round this off to like the first decimal place, it's going to be about 5.1. So we'll just call it 5.1 there. Okay, that's it for this video. You're going to finish the rest of these as an assignment. And looky down here on 1920, don't forget, if you're multiplying these together, you're going to get a second degree equation. Looks like you might need to use some of your skills in quadratics to solve those. So keep that in mind. And I will see you in class.